Hello friends, so I'm back with another lead code problem. So in this problem, it's called same tree. Basically, we've been given two tree, and we need to tell if they are same tree or not. And let's understand the definition of same tree. So first of all, these are binary tree. That binary tree means that we have the parent node, and then there are two childs. So when we have this kind of the structure, what we do is that we traverse to the left, right. So and then from that left, right traversal, we again check the child nodes until the entire traversal end up to the leaf node where we don't have any children. So this is how we typically traverse to the tree, right? And here we have been given a task where we want to compare two tree and see if they are same in terms of like the values. We need to compare the values. So if we see the example one, we have two trees. The first one has a root value 1 1, and then if both of them are equal, we do the recursion on the left tree for both the tree and check if their left tree values are same, and then also we do the recursion on the right side of it and see if the right side of the tree is equal. And we do this check for entire all the subtrees. So here we have we conveniently we saw that we just have you know the two just have one left and right, but you can assume that there is a one more uh, hierarchy for each of the tree, you know, and here as well, here as well, here as well, then here as well. So in that case, what we do is that we first compare the root, and then we recursively call for the same thing for left child, compare them. We call the right child, and compare them. So the next call would be basically to check if this subtree is same with this one, right? And this subtree is same with this one. So it's like that. So we do this operation recursively until we reach to the leaf node where both of them are null or either of them are null or so on. So we will eventually end up with the condition where both of them are null or one of them are null. Let's consider another example. So this one, right? So in this case, we have, okay, give me 1 second. So in this case, we have left child and right child, but there is no right child for the first tree and left child for the second tree. So what we can do here is that once we traverse for the left side, we see there is a value, but on this case we don't have any value, right? It's basically null. So these two are not equal, and then we return the false. Then again for this one, we compare the root values, it's the same. We check for the left value, and the left value for this one doesn't match. We can uh, return false immediately. So in order to make these two tree right, we have to have a case where all the values on the left side matches with the left side and right side matches with the right side. So that's the logic here. That's what we're gonna do. So mainly we have to compare the values. So the easiest case would be to check if p dot val if p dot val not equal to q dot val. So if we get this case, we can immediately return false because we know that the values are not matching. We kind of we don't have a choice, and we know the answer. We can immediately return false. But since we are doing p dot val, q dot val, we have to make sure that both these values exist, right? If even of them are null, we could end up being in null pointer. So if p equal to null and q equal to null, then we know that we have reached to the end of the tree and both of them are null. So that means we can return true because the values are matching, right? So both of them have the so for example, consider this case, we are comparing 1 1, we are comparing 2 2, and then in the next iteration we will be having null here and we will be having null here as well. So we basically traverse the entire left subtree and then we reach up to the null. So for that case, we know we can return true safely, and then we can check if one of the tree is null but other is not. So that can be a case as well, right? For example, example number 2, if you see, we if we go for the right part, we end up with the null, but here in the right part we have value. So if p equal to null and q not equal to null, in that case we can return false, because we know that we cannot we cannot call these tree equal. We immediately know this situation, right? So if p equal to null, and the same process is the reverse side of the condition, so q equal to null, and again we know that we can return false. So we have all the false cases here, mainly when things are not matching. We could have just think about that, oh, this is the condition enough, but we also make sure about the null condition, right? Otherwise, we'll having this issue. We can merge this into one statement as well, but I prefer to write it in a separate, just to have a better readability. Now all these things have passed, we can make a recursive call for this subtree. So far here we have we might be falling into some of the cases, but if we not, then we are basically having the p dot val equal to q dot val. Basically we have, let's say, this condition. So in none of these will be happy, right? So we'll go for the, that means we are on the two values are equal, right? So we kind of do the p dot left, we pass p dot left, and we pass the q dot left. So now we are basically calling the recursion. We're saying that, okay, this is okay, let's go to the left side, and we'll the iteration for the left part, and we also do the iteration for the right part. So here we do the p dot right, and then q dot right. Okay, and we quickly return this here. Okay, so first we did the root value comparison. Either of these cases are one of the case, then we kind of return true or false according to the script condition. But if both the values are equal, then we try to check the subtrees. In any of the situation, if it returns false, we know that this is an AND operation, right? And AND operation is like a short circuit operation. Basically, and if even like one false you get, the entire chain of the values is going to be false, right? So immediately if we return false, our tree will be end up into the giving the return. So for true, it has to return true for all the checks, but for false, as soon as we get the first false, the entire chain will be entire chain of fall will be false because of short circuiting, and we'll get the we get the answer immediately. So that's about it. Let's try to run this code and see if it executes properly. And it does. Let's try to run all the test cases. Okay, let's wait some time. It takes us to wait a few seconds. Okay, let's try to run it. I hope we are able to pass. Let me check some constraints. Number of nodes in the Buddha trees are 0 to 100. That's okay. Node value is minus 10 to 4 10 to. That's okay. It doesn't give us any edge cases to handle, so it's okay. We can submit it and see if it gets accepted. And it does. So that's about it. So thanks for watching this one. I'll see you in the next one. Thank you.